Now hopefully with this example 5, it starts to make sense about how we're setting the radius up for each of these shell methods. I have my curves. I have a line that's y equals 5. I've got this strange curve, that's hyperbola, y equal x plus 4 over x. So part of the curve is here, part of the curve is going to be down here, but I'm not interested in that because I only need the region that's contained by the curves. So that's this little nub right here. And I want to rotate this about the line x equals -1. Since that is parallel to the y-axis, it tells me I want everything in terms of x. Remember, the shell method is always backwards to what we're used to doing. If you revolve something about the y-axis, you're expecting everything to be a dy. But with the shell method, it will jump and it'll do the opposite axis, or opposite variable that you're with respect to. So let me show you how I set this one up. I have my volume equals 2 pi. We should be masters of this now. And in my region, I found that the two curves were going to intersect at x equals 1 and x equals 4. So I went from x equal 1 to x equal 4. And then again, I want to focus on this radius because I think that's what we're having so much trouble with. Think about the distance that I'm going to go, that I'm going to travel from start to finish. I've got 1 unit here and then 1 unit there. This thing's going to have to start at a value of 2 and it's going to have to end at a value of 1 plus 4 of 5. We'll mess this up here a little bit. Hopefully you can see what I'm referring to. It has to start at 2 and end at 5. And an easy way to check that then, when I wrote my radius, I said it was going to be 1. I know I'm over at -1, but I'm saying 1 plus x. So when I do the 1 plus a 1, that gives me that radius of 2 units. It's 2 units for my axis of revolution. So that's 2. And then I have to have a total unit length, a radius of 5. The 1 plus the 4 is 5. So this is showing that it'll actually start at 2 and end at 5. That radius jives with my understanding of how far out I need to start and how far out I need to end at. It says it should have a radius beginning length of 2 and an ending length of 5. 1 and 1 is 2. 1 and 4 is 5. So I like that radius concept there. And then for my height, it's just going to be the 5 minus this function here. And that's what I wrote. 5 minus the hyperbola. Now I did have to distribute the negative across the second curve, so it becomes 5 minus x minus 4 over x. You could type this exactly into the calculator the way you see this, with this being 2 pi, radius, height. Do your option 7 when you graph it, and you can tell it to start at 1 and end at 4, and you should get an answer of 40.557. And that's your setup for this shell method. Check and make sure that your radii are starting and ending where they are supposed to. I had to start at a length of 2 because here's my axis of revolution. It goes all the way to this, and then I had to end at an axis of revolution being 5. So that's why I said 1 plus x. I think if you check that on these problems, hopefully it starts to click as to why I set up those radii differently for the various problems. I'm looking at where it starts and where it ends and determining that length, making sure that that length jives with my picture. So now we have 5 examples, and hopefully this now makes everything a little more understandable with how to do the shell method for solids of revolution.